Hey Wildcats, today we're looking at Monday, April 29th, log function transformations part 1 on page 61. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at our notes. Logarithmic transformations, page 61. When f of x equals negative a log base 2 of parentheses negative bx minus h plus k, the negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of the b, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. And when it's minus k, it translates down. All right, if you would, update your notes. Now your notes are updated. Let's take a look at the example. All right, graph the exponential function f of x by transformation. Find and graph the inverse of f of x. Okay, so to graph 2 to the x minus 5, we're going to use our calculator. We're going to go to on new document, add graph. And let's see if I can brighten the screen just a little bit. There we go. All right, so you do 2 up key to the x, click to the right, minus 5. Menu, view, grid, line grid. All right, so you can see here that the asymptote is right here, which is negative 1, 2, 3, 4, 5. So negative 5. So your asymptote is y equals negative 5. Let's just graph that now. Now, asymptote is a dashed line. Okay. Now, let's look for points. Now, you can use the graph so we can see here that's negative 1, 2, 3, 4. So 0, negative 4. And then it looks like 1, negative 1, 2, 3. 1, negative 3. And then it looks like we can use 2, negative 1. And going along here, it looks like we can use 3, 1, 2, 3. Okay, that should be enough points to draw a curve. Now, we're going to do this function in orange. I'm going to do the inverse in green. Now, whenever you're doing inverses, you want to graph the y equals x line. Because if they're inverses, they reflect over that line. All right, so let's start filling in some of the information. Okay, transformations, there's only one, which is down 5 units. Okay, the y-intercept was 0, negative 4. Domain is negative infinity to positive infinity. And range would be from this asymptote going up, so that's negative 5 to infinity. Okay, now the inverse of an exponential function is a log function. Now, the key word is switch when you're doing inverses. So the asymptote was y equals negative 5. Now it switches and it's x equals negative 5. and that's a vertical line at -5. Okay, the point was 0, -4, and we actually have a couple points. That we're going to switch. First, we'll switch this one, so that'd be -4, 0. And we have another point, which was 1, -3, which is switches and becomes -3, 1. And this point was 2, -1, and again, switches -1, 2. Okay, and so let me just add that to here. So our points, original points were 0, -4, 1, -3, and 2, -1. So you can see here that we switch them. So our new points are -4, 0, -3, 1, and -1, 1, 2. So it falls along the asymptote and curves up. And you can see here that they reflect over the y equals x line. Now, keyword again, switch. So the domain was -infinity to +infinity. Now the range is -infinity to +infinity. And the range was -5 to infinity. Now the domain is -5 to infinity. Okay, go ahead and finish up example 1. All right, now let's take a look at example 2. And again, we're going to graph it using our calculator. So we're going to go to on, new document, no, add graph, and that's 2 up key x -1, click to the right, +3, menu, view, grid, line grid. All right. Now, we can see here that our asymptote is at 1, 2, 3. So let's do that. So our asymptote is at y equals 3. So we go horizontal line at that. Horizontal line, dashed line, I should say. Okay. Now, the last problem I showed you to get the points was with the graph. Now let me do it with the table. Control T. And let's go all the way over to -8. Starting there, and let's go until we find a good point. Our first point is 0, 3.5. So that's our y-intercept. 0, 3.5. So it's right there. And let's go ahead and write those points down because we know we're going to switch them. So 0, 3.5. Our next point is 1, 4. So 1, 1, 2, 3, 4. And then 2, 5. Then 3, 7. 3, 7. Okay. And remember, we're doing our function in orange. Okay. Now the transformations went to the right one. And up 3 units. Okay. Domain. we know is negative infinity to positive infinity, and range would be from this asymptote going up, so 3 to infinity. Okay, now the inverse of an exponential is a log function, and again the keyword is switch. So the asymptote was y equals 3, now it's x equals 3. Okay, now the points, again, we're going to switch them. So that's now 3.50415273. So 3.50, which is right here, 41527123. All right. Now, almost forgot, whenever you're graphing inverses, you want to graph the y equals x line. Because if they're inverses, they reflect over that line. Okay, so you can see here that they reflect over that line. Now, domain is now 3 to infinity, and range is negative infinity to positive infinity. So we'll go ahead and finish up example 2. All right, now let's take a look at example 3. All right, state the transformations, asymptotes, key points, domain, and range, and sketch a graph of each. So now, graphing, the log should be up there, but I don't know. I thought I fixed it, but nonetheless, the y equals is right there. All right, so let's graph that. So on new document, no, add graph. Let's try it again. On new document, no, add graph. So control log base 2 of x minus 6, click to the right, plus 4. Menu, view, grid, line grid. Now here you can see the asymptote is at 1, 2, 3, 4, 5, 6. Okay, so asymptote is at x equals 6. So let's go ahead and do that now. Okay. Now we need to get points. So we're going to go Control T, and we want to start. You can see how there's arrows. So let's start after 6. So a key point is 7, 4, and let's see if there's any others. 8, 5. So our key points are 7, 4, 8, 5. Okay, so let's go ahead and graph those. So 7, 1, 2, 3, 4, 8, 5. And remember, the log function we've been graphing has been in orange, and in this case, the inverse will be in orange. Because the log function I've been putting in green, and the exponential I've been putting in orange. Okay, so here's your curve. Now, remember when we're doing inverses, we want to graph the y equals x line. Okay, now domain for log is 6 to infinity, and range is negative infinity to positive infinity. Now transformations is right 6 units and up 4 units. All right, now the inverse is an exponential function. So the inverse of a log function is an exponential function. And again, with inverse, the key word is switch. Okay, so the asymptote was x equals 6. Now it's y equals 6. The point switch. So the points were 7, 4. So now it's 4, 7. And it was 8, 5. Now it's 5, 8. So 4, 7. 5, 8. Now, domain, remember, switch. So domain was 6 to infinity. Now it's negative infinity to positive infinity. And the range is now 6 to infinity. All right, so go and finish up example 3. All right, now let's take a look at example 4. Last example. All right, so we're going to start. Let me give you some time to get example 3. All right, now let's look at example 4. So on, new document, no. Add graph. Negative control log base 2 of x plus 4. Menu, view, grid, line grid. Now we can see here that our asymptote looks like it's at negative 1, 2, 3, 4. So we asymptote at x equals negative 4. Okay. Now we need points, so press Control T. And we're going to start all the way at negative 8 on the graph. Now you can see it's undefined at the asymptote. So the first good point, key point is negative 3, 0. Then negative 2, negative 1. That doesn't work. 0, negative 2. And let's see if that's enough points to get us a good graph. So negative 3, 0. Negative 2, negative 1. And 0, negative 2. Let's see if there's another point we can graph. 4, negative 3. And that's probably all the points we can use, okay? So let's just go ahead and add that to one of our key points, 4, negative 3. Now, if that's confusing to see, what you could do is come over here and make a table. So let's start with the first point. So negative 3, 0. Negative 2, negative 1, 0, negative 2, and 4, negative 3. Okay, and again, we've been doing our log function in green. And we'll do our exponential, which in this case is the inverse in orange. Now transformations reflect x-axis and then left 4 units. Okay, domain we know is from -4 to infinity, and range is -infinity to +infinity. Now the inverse is an exponential function. Now the asymptote, remember the key word is switch. So it was x equals -4, now it's y equals -4. Okay, now the points which were -3, 0 now are 0, -3, -1, -2, -2, 0, and -3, 4. Okay, so let's graph those. So 0, -3, -1, -2, -2, 0, -3, 1, 2, 3, 4. So this one is pretty crazy because it looks like they're almost the same graph. All right. Now domain is in switching, so -infinity to +infinity, and range is -4 to infinity. All right, so go ahead and finish up example 4. And that's it for the day. So once you're done, show me that. I'll put it in the grade book, and have a wonderful Wildcat day.